हरिः कर्ता।
So now let's look into the interquartile range. We have seen a range from measures of variability or spread. So now we will be looking into the interquartile range. So what is interquartile range? To understand interquartile range, you need to understand quartile or percentile. So the interquartile range is a measure of spread that is based on the quartiles of a dataset. Quartiles of a dataset. It's calculated as the difference between the third quartile and the first quartile Q1, Q3, the third quartile, and the first quartile Q1, which represents the 75th percentile and 25th percentile of the data set respectively. So if you are confused, I'm going to explain with a diagram. Don't need to worry. An infographic, I'm going to use it for the better understanding. The IQR represents the range within which the central 50% of the data falls, and it is less sensitive to extreme values compared to the range. So that is the reason we consider IQR. I am repeating again one more time. The IQR represents the range within which the central 50% of the data falls, and it is less sensitive to extreme values and compared to the range. Let's take now let's deep dive into the interquartile range. First, let's understand quartile and percentiles, then we will move on to the interquartile range. Okay, a quartile a quartile is the value. That's it. A quartile is a value that marks one of the divisions that breaks a series of values into four equal parts. I hope you got my point. So here we have 1,000 points or 1,000 cases. Let's take it as 1,000 cases. If you don't understand cases, then you consider as 1,000 records. If you don't understand records also, then consider it as 1,000 observations. So you have 1,000 observations. Now in this 1,000 observations, the minimum is 0, the first one, and then maximum is 1,000. Obviously we have 0 to 1,000. So 1,000 observations. The least, it started with 0 and then ends with 1,000. Okay. And then we have, what is quartile now? A quartile could be inside this. It could be 250th, 500th or 750th, whichever it may be, that marks one of the divisions. And quartile is the one that breaks a series of values into four equal parts. Now what we did, we have 1,000 observations, and 1,000 observations we made into 1,000 divided by 4. 1,000 divided by 4 will give you four equal parts. The first part is 0 to 250, second part is 250 to 500, and 500 to 750, and 750 to 1,000. So these are the four equal parts. So total we got the four quartiles: Q1, Q2, Q3, Q4. So total four quartiles. The median is a quartile and divides the cases in half. Now, so quartile is clear. Now percentile. Let's take, this is our data distribution. So these are the cases, and then these are the values. So each case, each observation holds a certain amount of value. That is how the data has been distributed across. But the bottom one on x-axis is the number of cases. Okay. Now let's take the percentiles. 25th percentile is a quartile that divides the first 1/4 of cases from the latter 3/4. So this is called a 25th percentile. 25th percentile is a quartile. So 25th percentile is equal to Q1. So what it does is 25th percentile divides the first 1 by 4 of cases. This is 1 by 4, 250 cases from the rest of 3 by 4 of cases. So this is our first quartile Q1 or 25th percentile. And similarly, this is 50th percentile, 50th percentile. This is 50th percentile. And in 50th percentile is nothing but your mean or median. Sorry, it's a median. 50th percentile is a median, and it's Q2, and it divides the cases in half. You see that here you have 500 this side, 500 this side, and exactly is that its center is called 50th percentile. So 50th percentile. Then you have the 75th percentile. In 75th percentile is a quartile that divides the first 3 by 4 of cases. See, first 3 by 4th of the total cases. That's 750 cases from the latter 1 by 4 of the cases. Okay. So here we have used three words. One is quartile, second one is percentile, and third one is percentage. Percentage, we all know 25th, 25 percentage of cases of 1000 is 250. That's it. There ends the matter. Whereas the 25th percentile is nothing but is equal to 20. The 25th percentile is the value which holds the 25 percentage of cases in total data set. And similarly, 75th percentile is a value till that you will have 75 percentage of cases from the total observations of the data set. So, and similarly, your quartile 1 is a value which is equivalent to the 25th percentile, and your quartile 2 is the value which is equivalent to the 50th percentile, and quartile 3 Q3 is a value that's equivalent to the 75th percentile. And now the interquartile range. The interquartile range is the distance or range between 25th percentile and 75th percentile. So this is our 25th percentile, and this is 75th percentile. The distance between the range between 25th percentile and 75th percentile is our interquartile range. So 750 minus 250 is equal to, sorry, as 750 minus 250 is equal to 500, and this is the interquartile range. This location exactly from here to here. So this is our interquartile range. So let's take a simple example first before we jump into the next one using pandas. Let me put it here. Interquartile range, IQR. Yep. So I will take the same data set from here. Let me copy this. Yep. So first let's calculate the quartile, first quartile. Okay. Let's calculate the first quartile. That's Q1. So Q1 is equal to data And if you want to calculate the quartile 1 Q1, then you have to use quant you see that quantile you have to use the quantile method. If you want to measure Q1, then you have to say 0.25, because that's the 25th percentile, or 25 percentage of cases uh, should come here below. It should hold 25th percentage of cases is. So let me see Q1, and it's 20. So we have 5, and so below here 20 is the quartile 1. Anyway, we'll do it with the real data also. And quartile and quantile in pandas, the method to calculate the quartile, the pandas uses the method quantile. So that's the reason sometimes I say quantile also, so don't get confused. Now calculate the third quantile. Sorry, I'll say third quartile Q3. So Q3 data quantile 0.75. It's 40. Here it is. So that's it. You can clearly make out. This is our quantile 1, this is our quantile 3, and obviously this is the last one. So in between, the range is between these two. Now to calculate the IQR, let's calculate the IQR, interquartile range. IQR is equal to Q3 minus Q1. So let me print the IQR now. Print interquartile range, that's IQR is IQR. That's it. The IQR is 20, because 40 minus 20 is your IQR. Okay, 40 minus 20. So this value represents the quartile, and this value represents the first quartile, and this value represents the third quartile, and the difference between this two quartile is interquartile range. Now let's take some concrete examples or real world examples so that you can have a clarity. So I'm gonna take again the players data. So soccer players, that would be much simpler. So let me take this here. So players and columns. Yes, now let me take calculation of first quartile. Exactly, let me take it here. So quartile 1, so we'll be taking the height. First let's see height and how it works. This is players height. So quantile remains same, and this one players height and quantile 0.75. So let's check before, let's execute this. And IQR is 15 centimeters. Fantastic. But let me check this one. Q3, how much we got? Q3 and Q1. Okay. If you see, Q3 is 185. and Q1 is 170. Obviously, the Q3 minus Q1, you'll get the 15. That's correct. So here, the quartile, let me put the values. If you see the values, uh, quartile 1, so 25 percentage. So 25 percentage of players having the height which is lesser than sorry, 25 percentage of players having the height up to 170 centimeters. Okay, and then remaining 50 and 75 percentage of our players are having the close height of 185 centimeters. It's not having the height of 185 centimeters, still 185 centimeters of height. So from that, okay, so the range, the interquartile range is 185 minus 170 will give you the 15 centimeters. So this is what the interquartile range. So if you see 50 percentage of soccer players uh, is having the height which with a range of 15 centimeters, with a range of 15 centimeters in that. Okay. Now let's take for the weight in kg. Let me call the Q3 Q1. Yep. Q3, that the third quartile or 75th percentile is 81 kg and Q1 is 61 kg. So 25 percentage of weights are lesser than 61 kg and 81 percentage of pupils, soccer players weights are lesser than 75th percentage of soccer players weights are lesser than 81 kg. So now the range, interquartile range, the most of the 50 percentage of soccer players weights are in between the 20 kg, with a range of 20 kg, with a range of 20 kg, and after that you will have the remaining 25 percentage is on top of that, maybe in between 81 to 218. That spread, it's a widespread, but the most density you will find in between 81 and 61. Okay, that's where the interquartile range will give you the more information. Here you will have the thicker density. So most of the players having their masses, their weights in between 61 and 81 values, quartile values.